Assalamu alaikum, dear students. Welcome to Mathematics Online. Today in this lecture, we will be discussing types of functions. Earlier, we have discussed the types of relations, and now we will be discussing the types of functions. Okay, I would like to recall the concept of the functions. A specific type of relation is called a function if every element of the domain has a unique image in the codomain. Okay, so keeping the definition in the view, we will go to the types. Here we have the first definition, that is one function, or it's sometimes called as injective function. A function f from x to y from the domain to codomain is said to be a one function or injective function if the image of distinct elements of x under f are distinct. Distinct means different. That's if we'll take the domain elements x1 and x2 such that f of x1 is equal to f of x2. This implies x1 is equal to x2. That means the range elements for two distinct range elements correspond to two distinct domain elements. Or we can say if the range elements are same, that implies the domain elements are same. Otherwise, this is mean one. Okay, we will be illustrating this with the help of examples. Next one is onto function, or this may sometimes be called as the surjective function. What is this? This is a type of function f from x to y. Uh, if every element of y means codomain, is the image of some of the elements of x under f. That's for every y, every element of the codomain. There exists at least one element x in x such that f of x is equal to y. This actually means that none of the elements of the codomain is left without mapping. Okay, there's at least one of its element in the domain that has been mapped with the element of the codomain. Okay, you can see now. So first of all, we discussed one function. One means different elements should have different images under the given mapping. So you see one has been mapped to A, 2 has been mapped to B, 3 has been mapped to D, and 4 has been mapped to C. So this is a one function because different elements are mapped to different elements of x1 set are mapped to different elements of set x2. So it's one. But the question is whether this is onto. The answer is no, because there exist elements E and F that have not been mapped to any of the elements of the domain set x1. So what about f2? F2 is not one because 1 and 2 are mapped to the same element to B. So distinct elements do not have distinct image here. Distinct elements, different elements 1 and 2 are mapped to same element to B. So therefore it is not one. It is many one. The question is whether this is onto. The answer is no, because once again, E and F have no pre-images. Okay, they are not the images of any of the elements of set x1. What about f3? You see, 1 and 2 have been mapped to A, so this is not one. But all the elements of x3 have been exhausted, so they have been used. So what about its subjectivity? Yes, it is subjective. It's onto. Now let's move to f4. 1 has been mapped to B, 2 has been mapped to C, 3 to A, 4 to D. Different elements have different images. Yes, and none of the elements of x4, that's codomain, is left alone. That means there does not exist any element that does not have any pre-image in x1. So all the elements have been exhausted in the codomain set. So therefore it is onto. So it is one and onto. It's injective and surjective. We will be defining one more special type of functions, that is bijective function. What is that? A function is said to be a bijective or function if it is both one and onto. Yes, this function f4 is one and onto. Okay. One more important point that's remarked here, it is that for a function to be onto, a range of f should be equal to y. Y means codomain. That means whole codomain set is the range of the onto function. Okay. So these were some illustrations for these types of functions. Hope you have got it. In the next lecture, we'll be continuing these exercises on functions. Thank you for joining the class.